So now we see that we finished that. Now we're going to move to the next one. So the next one is acceleration. We'll try to understand the acceleration of something that is moving. You know, when the object doesn't move, there is no acceleration. So something has to move in order to have some acceleration. So acceleration is a vector quantity. What is vector quantity? Vector quantity has two components, and the scalar quantity has only one component, but we're going to discuss it a little bit later, what is vector quantity. Let's understand what is acceleration before understanding what is vector quantity. Acceleration is delta b over delta t. So let's derive a problem, all right, as we promised to do. Let's say using this formula we're going to come out with a math problem, physics problem. A car uniformly accelerating from rest to 3 meters per second for maybe 10 seconds. We're going to write s for second. Find acceleration. Acceleration of this car. Okay? So let's see. So acceleration is delta b over delta t, which is b final minus b initial over t final minus t initial. I'm not going to draw this because this is a simple problem. So b final was, we know that b final was 3 meters per second, and b initial, the car was at rest. So b initial was 0. All right, the car was at rest, that's why. T final minus T initial, so T initial is 0, all right, and T final, so the entire journey took 10 seconds, so we're going to write 10 seconds, all right. So now we have 3 meters per second over 10 seconds, which we can write 3 divided by 10 is 0.3 meter per second square. So the velocity of the car was 0.3 meter per second square. Right? That's the unit of acceleration. We're going to keep that in mind. Right? So we just finished this one. Let's go to the next one. Next one talking about final, velocity final, right? Right. Maybe we'll be able to use this problem. So the velocity final is a car. Let's see, a car uniformly accelerating. No, we're gonna let's write some new question. I think this question is not good for this formula. B final, this time we try to understand the velocity final is velocity initial plus AT, right? So an object, a car with initial velocity, next time we're going to write initial velocity like this. So a car with initial velocity maybe 4 meters per second, uniformly accelerating accelerating 5 meters per second for 10 seconds. Find final velocity. Final velocity. We're gonna write it velocity, right? All right. So final velocity is initial velocity plus 2at. No, plus just at, right? So what is initial velocity? Initial velocity is 4 meters per second plus a is 5 meters per second square and t is 10 seconds. Right. Why this is 5 meters per second square? Because the car was accelerating for 10 seconds. So we have to keep that in mind. That's why we have it second square here. So 1 second, take away. So we left it 4 meters per second plus 5 meters. Well, 5 times 10 is 50 meters per second, which is 54 meters per second. So the car final velocity was 54 meters per second. All right. So we finish with this one. This beautiful mathematical formula, mathematical laws of physics. So let's move to the next one. Let's see how can we use that formula to come out with our own question, to solve that question, to understand what's going on inside. All right. Distance is, it says, distance is velocity initial times time plus half at square, right? So let's see whether we can use this formula, use this question. A car with initial velocity, that's condition met, uniformly accelerating, okay, that's there. Maybe we have to do some modification right here. Accelerating, maybe whatever we modify, we're gonna use the different color. 4 meters per second square. All right. Find what is car distance if it travel for 10 seconds. 10 seconds, right? So let's solve it. D is velocity initial times t plus a half at square, right? So velocity initial is simply 4 meters per second and t is 10 seconds plus half a is 4 meters per second square and t square, which is 10 square, 10 seconds square, right? Now, second cancel. So what are we left with? 4 times 10 is 40 meters plus 2 goes to 4 twice. So 2 times, and then the second is, okay, so this is 100 s square because 10 square is 100 s square cancel, and then 100 times 2, 200 meters. So 240 meters. So the distance the car travel is 240 meters. All right, so we just finished this one as well. Let's move to the next one. Next one is final velocity, finding final velocity. We did this kind of problem before, so that shouldn't be a big deal this time. So final velocity square is velocity initial plus 2AD. All right. So velocity initial square plus 2AD. So let's see whether we be able to use this cushion. A car with initial velocity condition met uniformly or consistently. Let's not keep using uniformly. Consistently. Right? Consistently accelerating, okay, this condition met 4 meter per second squared. It doesn't have to be 4 all the time. Let's say 6. What is car distance? Well, distance is given this time. So you're going to say what is car final velocity? Final velocity. What is car final velocity? If it travel a total 20 meters. If you travel 20 meters. If you travel 20 meters. Okay. Let's see. So velocity final square is velocity initial square, which is 4 meter second square plus 2. Acceleration is 6 meter per second square, and distance is 20 meters. All right. So now we have 16 meter square second square plus, okay, so 40, 46, 240. So 240 meter square second square. That's the velocity final square. So then the velocity final square is 16 and 240 is 256 meter square and second square, right? So B is simply square root of 256 meter square second square. So what is the square root of 256? Let's see, 256 is 16. So velocity final is 16. When you take the square root of m squared and s squared, you get meters per second. So the velocity of that car was, final velocity of that car was 16 meters per second. So we just finished this one as well. So we are making good progress. I hope you understanding. What we are doing, we are using physics, beautiful physics formulas, mathematical physics laws to solve the physics problem. Let's use the next one. Acceleration is, of course I'm going to do a little difficult problem as well, but let's get the hang of it before solving the difficult one. All right, that's the plan. So acceleration is, next formula is acceleration is F net over mass. All right, so let's, as usual, make a problem. Remember, in our problem, we have to satisfy this condition. We have to have net force and we have to have mass, okay? So let's say a net force of, a 100 Newton force applied exerts, I guess, to move a 50 kg 50 kg box from maybe lobby to elevator. Okay, from maybe lobby to elevator. So find acceleration. Okay, so let's see how we can solve that. All right, so force is Newton. So what force we exert? 100 Newton. So 100 Newton. And the mass of the box is 50 kg. So 50 kg. All right, so one thing we have to remember that Newton is kg meter per second square. All right, so we have to keep that in mind. Otherwise, we're not going to get our math correct. So let's write Newton with green. So 100 Newton. Right? I have a reason for that. All right, so 100 kg is on the upstairs, so we write kg. Meter is on the upstairs, we write meter. Second square is on the downstairs, so we write second square. Now we go back to 50 kg, we write 50 kg. That's what unit we end up with. 50 goes to 100 twice, kg cancel. So acceleration is 2 meter per second square, 2 meter per second square. Is this a good unit for acceleration? Yes, it is. So the box was moving at the rate of 2 meter per second square. So what is rate? In this case, the rate is acceleration. In the definition of physics, we say the physics is, especially Newtonian physics, is all about the relationship between motion and rates. This is one of the rate. Acceleration is one of the rate. What is the another rate? So rate is speed, velocity, and acceleration. Okay, this is a good time to talk about the scalar and vector quantity. So you see the speed is a scalar quantity. You see velocity is a vector quantity, and acceleration is also a vector quantity. Why is that? Because speed only care about how fast something moves. But velocity not only care about how far something is moved, also care about the direction. And so does the acceleration. So the velocity is change of position over change of time, and acceleration is change of velocity over change of time. We're going to go over and over this thing again until you get the hang of it. So we just finish with this one. In fact, we are doing that, we're doing something that with the vector quantity.